Hello and a very warm welcome. Today I want to share with you this picture. Not a terribly good or attractive picture, but a very, very important one. This picture was taken on Traprain Law in East Lothian in Scotland. Some people have been a little unhappy about how much detail I've given about where I was standing when I took some of the pictures that I've been sharing with you recently. Well, this is where it was, and you can go and look it up if you want to find out more. I will be covering exactly where I was in this particular video, so hopefully that won't be a problem. Now, this picture, you will be not at all surprised to learn, proves that the Earth is not flat. And it does this in two ways. Before we look at what those two ways are, I want to explain a little bit about where I was and identify some of the features that are in this picture, particularly this wind turbine and this hill and this building. So here we are on Google Earth, and Traprain Law is here where I have this particular pin. So Traprain Law is a hill, sort of this teardrop shape. North is at the top of the screen. Let's take that pin away. There is a car park just here. If you want to go and take your own pictures from Traprain Law, I urge you to do so. It's a wonderful place to capture some brilliant shots that proves the Earth cannot be flat. And whether you're a flat earther or a spherical Earth believer, a normal person, as I prefer to call them, then this is a great place to go to get some really good evidence. Next to the car park, we have a little picnic area, a couple of information boards, and then there's a stile. You cross the stile and walk up this footpath. It gets pretty steep. A little bit of it here is fenced off, and as you clamber up, you get all the way up to the top here, 221 meters. Now, the last time I was there, I was in a hurry, but I was able to stop and just holding the camera by hand, take shots at different elevations as I went up the footpath. So these were the places where I stopped to take pictures. And today we're interested only in the third location. Now I want to establish the elevation that I was actually at when I took this particular shot. And to do that, I've overlaid a map, a topographic map, and we can click on the topographic map here on the website and get an elevation. But what is easier to do here perhaps is just read off on the contour lines, because they happen to fall very close to a contour line. First of all, just to show you that the map is well lined up, if you look at the footpath, which is represented in the dotted lines, if you look at the road, you can see that it's very well lined up. And if we zoom out on this shot, you'll see that it really is lined up very well indeed. Here we go. So all of the roads line up really nicely, as do the footpaths and so on. So we can reliably read off the contour lines to get our elevation. The 120 meter contour line is conveniently labeled here. So the next one is 130, the next one is 140, and this one is 150 meters. We can also read down from the 200 meter contour line, which is the slightly darker one here, to 190, 180, 170, 160, and 150. So I was at this point here, 150 meters above sea level. The hill and the wind turbine and the building in the photograph I showed you are located north of Haddington here. So the building is the Garleton Lodge, and the hill next to it is this hill here. And I've determined the elevation of that hill in a very similar way to the way that I did for Traprain Law, although on this occasion the contour lines are very spaced out. And so I've elected to click on the highest point that I could find on the hill. If I do this, you can see that there's a lot of spacing between the contour lines. So we've got 140 meters here, but then a long gap to the top of the hill and no other contour lines. So for that reason, I've clicked on it and got an elevation of 489 feet, which translates to 149 and a bit meters. So almost exactly the same height as the camera was on top of Traprain Law. No, not on top of Traprain Law, sorry, halfway up Traprain Law. Now we also have a wind turbine in the shot, and the wind turbine is located in the middle of this field. We can't see it in the 2009 imagery that's on the screen at the moment, but if we look at later imagery from 2018, we can see the turbine very clearly. Now this is quite a small wind turbine that services this farm down here. The farm, we can confirm if we go down to street level view. The farm is down at the end of this lane, and it is Alderstone Mains farm, and here is the wind turbine. It looks as if it's in the far corner of the field, but that's a bit of an optical illusion. The field obviously slopes away down towards where these trees are, and as we saw from the aerial shot, it's actually pretty much bang in the middle of the field. So as I said, it's not a very tall turbine, but we want to know exactly what elevation the turbine is at. So the base of the turbine from the topographic map is around 134 meters above sea level. And I was able to find out the actual elevation of the turbine after quite a lot of detective work. It's Alderstone Mains farm at Huntingdon near Haddington in East Lothian. And these columns tell you that there was one turbine. This is a planning consent form. So the green ones have received planning consent. The red ones have been rejected. White ones presumably are still pending. We have a 24-meter elevation for the turbine hub, or height for the turbine hub. We have a 10-meter blade length and a total height, maximum height of 34 meters. And just to confirm that that is what those columns actually mean, here we can see number of turbines, which was 1, the hub height, which was 24, the blade length, which was 10, and the total, which is the two added together, of 34. So this was the maximum turbine height that planning consent was awarded for. So it cannot be taller than that amount, but it could be shorter. However, we'll assume that they built the turbine that they requested and those heights are accurate. Now, how does this photo prove that the Earth is not flat? Well, I've enhanced it very slightly just by adjusting the levels to make things stand out a little bit more clearly. We know our camera height is 150, maybe given I was holding it sort of chest height, camera sort of chest height, up to perhaps as high as 152 meters, although probably nearer to 151. The hill height was 149 meters above sea level, so almost exactly the same. We're looking very slightly down towards the top of that hill. The turbine hub height is 158 meters. Now, if we draw a line straight across the screen, we can see that the turbine hub should be a little higher than the line that touches the top of the hill here, because it's 9 meters taller. And it's not touching it's not above that line at all, it's right on that line. So we know that the camera must have been rotated very slightly down to the right and up to the left. Sorry, it was rotated the other way. But to compensate, we need to rotate in this direction to get the thing level. So now, if we put a horizontal line across the screen level with the turbine hub, this comes to above the hill on the right-hand side. And if we put a line that hits the top of the hill, it strikes the turbine tower a little bit above halfway down. Turbine tower is 24 meters tall, and we want this line to cross it 9 meters from the top. Given that total height is 24 meters, I think this is pretty accurate. I haven't counted pixels or made measurements precisely, but it looks pretty good to me. So what does this tell us? Well, it tells us that we now have the picture level, and that our eye level height is where the red line is. It's just above the top of the hill. Anything that is taller than 150 meters or thereabouts above sea level must be above that line if the Earth is flat. It's a simple law of perspective or law of geometry that cannot be disputed. Well, it can be disputed, but if you're going to dispute it, you're going to have to prove that it's wrong. This is well-known, accepted fact that if our camera level, our eye level, is at 150 meters, then anything, if we could line that up with something else 150 meters on a flat surface, then anything else that is above 150 meters must be above the line, and anything else that is below 150 meters in height must appear below the line. Simple geometry, simple truth. So, knowing that, we find that on the left-hand side of the screen here, we have a hill in the far distance. That hill is Meikle Bin. It's 91.8 kilometers away, near to Glasgow, and it is 570 meters above sea level. Yet nearly all of Meikle Bin appears below the line, and only a tiny bit appears above the line. We should have 150 meters of Meikle Bin below the line, and 420 meters of Meikle Bin should appear above the line if the Earth is flat. If the Earth is spherical, then, as we shall see in a moment, there's no problem, because the curvature of the Earth will make Meikle Bin's effective height in our field of view drop so that it can be below the line. Just a quick confirmation of this rule, this law, this fact of geometry is shown here. If you've seen my other videos, you've seen this before. We have some cans laid out in pairs on a level floor. floor is level, confirmed by this laser that's pointing to the wall at the far end, just a few millimeters above the floor surface. Notice that the silver cans, although they get smaller and smaller the further they are in the distance, apparently smaller in our field of view, a smaller angular size, they can never, the base of that can never drops below the red line. And if there were another 100 cans going further and further and further into the distance, they would get progressively lower and lower and lower here, but the base of those cans would remain on the red line. The same with the orange cans. Although they get smaller in angular size, they do so only from the bottom up. The top of the can will always remain on that red line. This is just a simple fact. So let's have a look on a curvature calculator. This is Walter Bislin's curvature calculator, and it handily puts a flat Earth and a globe Earth side by side. I've entered the figures for the Garleton Hill at 149 meters above sea level, with our eye level at 150 meters. So there's a little gap between the two. The same here on the flat Earth. Equal bin in the distance on a flat Earth, most of it should appear above eye level and well above the height of the hill here. On a globe Earth or a spherical Earth, then Meikle bin appears below the height of the hill in the foreground. So our globe Earth observation matches, also our real Earth observation matches our globe Earth prediction. Our real Earth observation does not match the flat Earth prediction. Going back to our PowerPoint here, we can look at the view from side on in diagrammatic form. Now it's to scale, but different horizontal and vertical scales. So this is 90 kilometers from Traprain Law, 92 kilometers from Traprain Law to Meikle bin, and the scale in meters, vertical scale, is much more exaggerated. If it was done to scale for both, then the triangles would be so small you could barely see them. But it illustrates the point that with a camera at 150 meters on Traprain Law, we're looking along an eye level line on a flat surface. We should see only part way up Meikle bin. And we've already seen this confirmed in the curvature calculator. Just for completeness sake, this is where the wind turbine would be on this diagram, and it's just poking above the eye level line. However, I said that the photograph showed that the Earth cannot be flat in two ways. And the second way is that not something that's in the photograph that's in the wrong place, but something that we can't see in the photograph that if the Earth was flat, we ought to be able to see. Halfway between Meikle bin and Traprain Law is the Queensferry Crossing Bridge. The central bridge tower is 210 meters tall, and the south tower is 202 meters tall. The north tower is also 202 meters tall, and that would be outside our field of view. We should see 50 to 60 meters of each of those two bridge towers, the central and the south tower, above our eye level line. And because most of the hills in the area are a little bit lower than Garleton Hill, and we are looking down, we should be able to see plenty of the bridge towers above those hills. There may be 140 meters, not 149 meters. Yet in the picture, we don't see those bridge towers at all. The central tower should be above this point between the building, the Garleton Lodge building, and the hill. Should be somewhere here. And the central tower should be the southern tower should be halfway between the building here and the wind turbine. So in this sort of area here. And they should be protruding well above the height of the top of the hill here, let alone well above the height of these trees or the height of this building. And yet they're not visible at all. We can use the curvature calculator to demonstrate that those bridge towers should indeed be present. So if we replace the Meikle bin here, we can't put a third structure in, unfortunately. If we replace Meikle bin with the bridge towers at 46.5 kilometers and 202 meters, we'll go for the lower one, and we'll change the shape to a rod. Be more like a bridge tower. And let's zoom in a little bit just to make things a little bit more clear. We're going to have to pan things a little bit over this way. So we can see that on a flat Earth, the bridge tower protrudes well above the top of the hill, the Garleton Hill, and well above eye level. The other hills are a little bit lower, and so even more of the bridge tower should be visible above them. On a spherical or globe Earth, the Garleton Hill is higher than the bridge tower, and so we would expect the bridge tower to be hidden behind Garleton Hill. It would also be hidden behind a lower hill than the Garleton Hill. If we reduce the height to 140 meters, which is more like the height that is actually present next to the Garleton Hill, we see that 140 meter hill will still conceal the bridge tower on a spherical Earth. On a flat Earth, the tower would still protrude considerably above the top of those hills. In fact, almost half the tower here would be visible, because we now are looking down over 140 meters from a camera height of 150 meters. So the question is, why can't we see the bridge towers at all in this picture? Even allowing for the fact that there are trees here and a building here, the towers should be higher than the top of this hill, and yet they're completely invisible. And that is only possible if the Earth is not flat. If it's spherical or perhaps some other shape, you can explain this picture. But if it's flat, or it cannot be flat because this picture was taken. This is impossible on a flat Earth. Now, I want to show you the video clip that I took in its entirety, just so that you can see. It's only a minute long, so it won't extend this video by too much. So that you can see where I was when I actually took the video. I may pause it briefly. So here you can see the footpath coming up, and it comes around here and doubles back on itself, and I'm at the point where it doubles back on itself. You can see we're looking down quite a long distance. Most of the Traprain Law Hill is actually sort of quite steep from this grass bank here down towards this stone wall. You can see looking up the hill we still have a fair way to go. We're at 150 meters. The total climb is just about 100 meters in elevation. The road is at 100 meters above sea level. So the total climb is about 100 meters, and I'm about halfway up at this point. This is the Hopeton Monument. Here is the hill beside Garleton Lodge. And as you can see, the camera is wobbling around. I was a little bit out of breath and it was windy. And I'm holding the camera by hand. I didn't have time to set up the tripod. There is Meikle Bin, and you can see the wind turbine rotating there. And we pan across towards Edinburgh. Arthur's Seat there. There's Haddington down there. And zooming back out, you can see how high we are above the local landscape. So it's absolutely clear this particular picture is impossible to take on a flat Earth.